In this last screencast for Chapter 6, we discuss linear equations and inequalities. We begin our discussion of equations and inequalities by considering how they can be manipulated without actually altering their solutions. Two different equations or inequalities that have the same solution set are called equivalent equations. So for example, x plus 1 equals 7 and x minus 3 equals 3, these are called equivalent because they both have the same solution, namely x equals 6. So equivalent equations and inequalities can be created as follows. So let's talk about equations first. Adding, subtracting, multiplying, or dividing both sides of an equation by the same non-zero amount will yield an equivalent equation. For inequalities, the same is effectively true with a small addition. Adding, subtracting both sides of an inequality by the same non-zero amount, or multiplying or dividing by the same positive amount will yield an equivalent inequality. However, if you multiply or divide an inequality by a negative amount, the inequality symbol will need to be reversed in order to obtain an equivalent inequality. Before moving on, let's take a moment and understand what this last sentence here is saying. So suppose you had the inequality 2 is smaller than 4. Now that is definitely true. 2 is less than 4. So suppose I multiplied both sides of this inequality by, say, a negative 3. If I multiply both sides by a negative 3, I arrive at negative 6 is less than negative 12. So I did the same thing to both sides of the inequality. And notice the inequality that I arrive at is false. Negative 6 is not less than negative 12. Negative 6 is actually larger than negative 12. In order to make this inequality true, I need to reverse the direction of the inequality symbol. In other words, to make this inequality true, I need to rewrite it this way. So this is an illustration of what happens when you multiply or divide an inequality by a negative amount. You will always arrive at an inequality that is false unless you reverse the direction of the inequality symbol. So just a recap. If you multiply or divide an inequality by a negative amount, the inequality symbol has to be reversed in order to obtain an equivalent inequality. Now we're ready to talk about equation solving. In other words, finding a solution. A general rule in solving any equation or inequality is to always look for the simplest possible equivalent equation. There are many different kinds of equations and inequalities, but today we're going to focus on those which are equivalent to linear equations and inequalities. A linear equation involving a single variable x is an equation of the form ax plus b equals 0, where a and b are real numbers, they're known, and a is not 0. Replacing the equals with one of the inequality symbols yields a linear inequality. So, for example, 12x minus 9 equals 0 is an example of a linear equation. To see this, recall that a linear equation has the form ax plus b equals 0. And you can see that 12x minus 9 can be rewritten as 12x plus a negative 9 equals 0. So you can see that the 12 is playing the role of the a, here's the x, and the negative 9 is playing the role of the b. Also, 1 minus 2r equals 0 is linear. To see this, I would rewrite 1 minus 2r as 1 plus a negative 2r equals 0, which can also be written as negative 2r plus 1 equals 0. This equation is also in this form. You can see that the negative 2 is playing the role of a, the r is playing the role of x, and the 1 is playing the role of the b. So both of these are examples of linear equations. This equation is not linear. Notice that the variable here, t squared, the variable here, t, is squared. A linear equation will only have one factor of the variable. It cannot have more than one factor. So why are we focusing on linear equations? Well, you can see below, linear equations are easily solved using the ideas that we discussed above. So, for example, here is a linear equation. If we want to determine the value of x that satisfies this equation, what we can do is create equivalent equations that are simpler than this one. And our goal in the end is to arrive at an equation that is equivalent to the equation we started with, and this equation will tell us precisely what the value of x must be in order to satisfy this equation. So our goal is to repeatedly do things to the equation that cause us to obtain equivalent equations, with the goal of getting the simplest possible equivalent equation, namely the equation where the variable is all by itself on the left side. To do this, we look at the left side of our equation and we look at the operations that x undergoes. X gets multiplied by a, and then we add b. So in order to get x all by itself, these two operations, adding b, multiplying by a, they need to be reversed. We need to undo them. We start with the last operation that was performed, namely adding b. So what we do is we subtract b from both sides of the equation. This will give us an equivalent equation. If I subtract b from the left side, b minus b is 0, and I'm left with ax. Subtracting b from the right side gives me negative b. So this equation right here is equivalent to the equation up here, but it's a little bit simpler. So now, again, our goal is to have an equation where x is by itself. Currently, x is multiplied by a. So if we want to undo this multiplication by a, what we need to do is divide both sides of the equation by a. So that's what we're doing here. We're dividing both sides of the equation by a. And notice on the left side you have a common factor of a in the numerator and in the denominator, and they can be canceled. The result is just an x left on the left side. And on the right side we have minus b over a. So by simply undoing all of the operations that involve x, we are left with an equation where x is all by itself, and we're told on the right hand side what x must equal in order to satisfy this equation. So in the next example we will practice what we've just been talking about. Example 6.11. Let's look at part A. So in this example I have also written out what we were just discussing in the previous illustration above. So our goal, if possible, is to convert the equation into an equivalent equation of the form x equals something, just like you saw above. And we do this by strategically adding, subtracting, multiplying, and dividing both sides of the equation by amounts that simplify the resulting equation. So for this equation right here, our goal is ultimately to rewrite that equation in an equivalent form that looks like this. So we will have to figure out what number goes in that spot, but our goal is to go from this to this. So let's take a look at the equation, and in particular let's look at the left-hand side. It's quite complicated. There are several operations that x undergoes. X gets multiplied by 2, then we subtract 1, and then we divide by 5. If we want to get x all by itself, all of these operations need to be undone. We usually begin by undoing the last operation that was performed. In this case, that's the division by 5. So what will undo division by 5? Well, multiplying by 5. So we begin by multiplying both sides of our equation by 5. So you can see what happens. The 5's cancel. Why do they cancel? Because this 5 is like 5 over 1. So the 5 is in the numerator. And recall, if you have factors that are common to the numerator and denominator, you can cancel them. So the result of doing this is you arrive at an equation 2x minus 1 equals 35. This equation is equivalent to this equation, but is slightly more simple. Now let's try to simplify it further. I need to undo the last operation performed. In this case, that's subtracting 1. If I want to undo this, I will add 1 to both sides of the equation. So I take the 2x minus 1 and I add 1 to it, and then I take the 35 and I add 1 to it. The result, notice that the negative 1 plus 1 gives a 0, so we're left with 2x equaling 36. Again, this equation is equivalent to the last equation, which is equivalent to this equation. So all three equations have the same solutions. Now we need to simplify a bit more. X is currently multiplied by 2. We need to undo the multiplication by 2. And I do this by dividing both sides by 2. So I take my 2x and I divide it by 2. I take my 36 and I divide it by 2. Notice that there's a common factor of 2 on the left-hand side in both the numerator and the denominator, which can be canceled. This leaves me with an x on one side and 18 on the other. So we've done it. We now have the kind of equation that we were looking for. The missing number is 18. So if we've done our work correctly, when x is 18, this equation should be true. So let's check to see if that's the case. So we're going to do a quick check on the side over here. I'm going to take 18 and I'm going to substitute it in for x. And let's see if we get 7. 2 times 18 is 36. So 36 minus 1 divided by 5. 36 minus 1 is 35. Divided by 5 gives us 7. So it does check out. We were supposed to get 7. Okay, now let's have a look at our part B. Notice first of all this is an inequality. Notice also that our variable is on both the left and the right sides of the inequality. Our goal is going to be to get our variable on one side. So our variable will be on one side, and then we will either have a less than or a greater than. We'll have to figure that out, and there will be some number on the other side. That's what we're striving for. So let's see what we can do to make this inequality a bit simpler? Well, one of the things that makes this inequality look complicated is this division by -2. What could we do to both sides of this inequality to undo the division by -2? Well, multiplying both sides by -2 should work. So we begin by multiplying both sides of this inequality by a -2. And notice that I have to write the right-hand side in this form. I need to put the 8 plus y in parentheses to make it clear that the -2 is multiplying the whole sum. If I didn't put the 8 plus y in parentheses, if I simply put a dot right here, a multiplication dot, it would look like I was only multiplying the -2 by the 8 and not by the whole sum. So it's really important to remember parentheses right here. Now, notice we have multiplied an inequality by a negative number. So what do we have to do with the inequality symbol? In order to arrive at an equivalent inequality, we need to reverse the direction of the symbol. It was a less than, we need to have it be a greater than. So notice, this -2 is like -2 over 1. There's a common factor of -2 in the numerator and denominator, which may be canceled. So our resulting inequality is -y plus 3 is greater than. Now let's look at the right-hand side. I believe we could simplify the right-hand side by actually performing this multiplication. We've done this before. We used the distributive property to do this. So we take the -2 times the 8 and we arrive at a -16, and then we take the -2 times the y and we arrive at a -2y. So the resulting inequality is equivalent to the one we started with, but just a little bit simpler. Now our goal needs to be to get y by itself. So currently we've got y's on both sides of the inequality. In order to arrive at a value, to arrive at one factor of y on one side of the inequality, let's go ahead and add 2y to both sides of the inequality. So I'm going to take -y plus 3 and add 2y, and then I'm going to take 16 plus a -2y and then add 2y there. So I've added 2y to both sides of the inequality. Notice adding the same amount to both sides of an inequality doesn't cause you to need to change the direction of the inequality symbol. When we do this, notice we have a -2y plus 2y, and they cancel and leave 0. So the resulting inequality becomes, well, let's look at the left side. Notice we can do some simplifying here. We have like terms. -y plus 2y, that yields a positive 1y, or y. And then we add 3 to that, and this has to be greater than -16. We're getting closer to our goal. Remember, our goal is to get y all by itself. We have y plus 3 on the left side. So we need to undo the addition of 3. What will undo addition of 3? Well, subtraction of 3 will do that. So I take my left side and I subtract 3 from it. And then I also subtract 3 from the right side. Subtracting 3 from both sides does not cause us to have to reverse the inequality symbol. It's fine the way it was. So when we do the subtraction, notice on the left side we have 3 minus 3. That's 0. So we have y is greater than. On the right-hand side, we have -16 minus 3. That's -19. So we've arrived at our goal. So what we've learned is that if y is a number that is larger than negative 19, for example, negative 18, negative 17, negative 18 and a half, 0, 24, 1,000, any number bigger than negative 19 should satisfy this inequality. Okay, now let's go ahead and look at part C. In this equation, again, notice that the variable v occurs on both the left and right sides of the equation. Also notice that the left-hand side of this equation is a bit more complicated. In fact, the left-hand side of the equation looks like an expression that you would have simplified in an earlier screencast. In a situation like this, it's best to try and simplify any part of the equation that you can before doing any solving techniques. So let's go ahead and simplify the left-hand side. So notice that you are subtracting a large quantity. Right here you're subtracting 2 times the quantity 1 minus v. You're subtracting that from 4v. The suggestion I made earlier is that whenever you subtract large quantities, that you write all subtractions in terms of addition. So here we would rewrite this as 4v plus a negative 2 times 1 plus a negative v, and this equals 3v. Now we can use the distributive property. 4v plus, use the distributive property right there. Negative 2 times 1 is a negative 2, plus negative 2 times a negative v is a 2v, and this is equal to 3v. Now, notice that there are like terms now. We have 4v plus 2v, that's 6v, minus 2 equals 3v. So we have now simplified the left-hand side of the equation. This is in simplest form because there are no like terms left. Now we can go ahead and try to solve this equation. The variable is still on both sides of the equation, so let's do what we can to get the variable on just one side. There are two ways you could do this. You could either subtract 3v from both sides of the equation, or subtract 6v from both sides of the equation. Either approach is fine. Let's just try subtracting 6v from both sides. So we would have 6v minus 2 minus 6v, and 3v minus 6v. Well, notice on the left side, 6v minus 6v is 0, so we arrive at a negative 2 on the left side. On the right side, 3v minus 6v gives a negative 3v. So we're getting close to having this equation solved. Remember, our goal should be v equals some number. We're close. Currently, we have v being multiplied by a negative 3. In order to get v by itself, we need to undo the multiplication by negative 3. We do that by dividing both sides by a negative 3. So I'm going to take the negative 2, divide that by negative 3, and I'm going to take the negative 3v and divide that by negative 3. Notice that gives us a common factor of negative 3 in the numerator and denominator, which can be canceled. Now v is all by itself, and we have v equaling negative 2 over negative 3. Now, this fraction can be simplified a bit. Negative 2 is negative 1 times 2, and negative 3 is negative 1 times 3. And notice those negative ones can cancel, and you're left with 2/3. Now let's go ahead and look at part D. In this case, the equation involves fractions. The variable occurs on just the left side of the equation, but the variable is wrapped up in these fractions. So in order to get the variable x by itself, we're going to need to undo these fractions, so to speak. A useful tip in situations like this is to multiply both sides by the common denominator. So in this particular example, the common denominator would be 4. So let's try and multiply both sides by 4. So I multiply the left side by a 4 and the right side by a 4. Now when I multiply the left side by a 4, notice that the result is I have a number times a sum. Anytime you have a number times a sum, you can perform the multiplication using the distributive property. So I can rewrite this as 4 times x over 4 plus 4 times x minus 1 over, x minus 1 over 2. And this must equal 20. Notice that the 4's can be written as fractions, 4 over 1. So in the case of the first term here, you have a 4 in the numerator and a 4 in the denominator. They are both factors and they are eligible for canceling. In the case of the second term here, notice that the 4 and the 2 share a common factor of 2. So I can rewrite the 4 as 2 times 2 and then cancel out one of the factors of 2. So I'm left ultimately with an equation x plus 2 times x minus 1 equals 20. This equation is equivalent to the one we started with. It's just a bit simpler. Now look at the left side. The left-hand side is still a bit complicated. In particular, you can see there's a multiplication to be performed here. And we could use the distributive property to do that. So let's go ahead and rewrite the left-hand side with addition. So plus a negative 1 equals 20. And now if we use the distributive property, we have 2 times x, that's 2x, plus 2 times a negative 1, that's a negative 2, and this equals 20. Notice that we also arrive with some like terms. X plus 2x is 3x, and so really this is 3x plus a negative 2 equals 20. So again, we have an equivalent equation, but it's simpler than the one we had earlier. So if we want to get x by itself, which is our goal, we're going to need to undo these operations right here. So currently we're adding a negative 2 and we're multiplying by 3. To get x by itself, we're going to need to do something that undoes addition of negative 2. Well, what will undo addition of negative 2? Well, adding 2 should do that. So we're going to take our 3x plus negative 2, and we're going to add 2 to the left side, which means we're going to add 2 to the right side. When we do this, the negative 2 plus 2 yields 0, and we're left with 3x equals 22. Now, to get x by itself on one side, we need to undo the multiplication by 3. To undo multiplication by 3, we divide by 3. So I'm going to take my 3x and divide it by 3. I'm going to take my 22 and divide it by 3. Now I have common factors of 3 that are eligible for canceling, and when I cancel, I'm left with x equals 22/3. And this should be the solution of our linear equation. Okay, let's go ahead and look at our last example, example 6.12. Solve each equation for the indicated variable. Okay, in part A, notice that this equation here involves two variables, x and y. The equation is linear because there's only one factor of y and one factor of x. In other words, you're not seeing x squared or y cubed or x times y. You're just seeing single factors of the variables x and y. Our goal is to solve this equation for the variable x. So in other words, our goal is to arrive at an equation that has this form. Now, what about the other variable y? Well, the other variable y is going to show up in the question mark here. Currently, this equation has the variable y solved for. And really what we're doing is we're reversing the roles of x and y. So in the end, the variable x will be solved for, and the variable y will sit here somewhere in the right-hand side, just like how currently x is sitting here in this expression on the right-hand side. So we're really just exchanging the roles of x and y here. So as far as solving for x is concerned, you're going to have to imagine that y is just some number you know, and your goal is to get x all by itself on one side of the equation. So let's look at the right side of the equation. In order to get x by itself, we need to undo all of these operations. X is multiplied by 3, we subtract 6 and divide by 2. We start by undoing the last operation, namely the division of 2. We undo that by multiplying both sides by 2. So I'm going to multiply the 2 by the y, and I'm going to multiply 2 by the 3x minus 6 all over 2. Now remember, that 2 is like 2 over 1. When you multiply these fractions on the right sides, notice the factor of 2 in the numerator will cancel the factor of 2 in the denominator. So you're left with an equation 2y equals 3x minus 6. This equation is equivalent to the one we started with. Now, let's focus on undoing the subtraction of 6. We undo this by adding 6. So I'm going to take my 2y and add 6 to it, and I'll take the 3x minus 6 and add 6 to that. On the right side, negative 6 plus 6 is 0. So what we're left with is an equation 2y plus 6 equals 3x. We're almost there. Again, our goal is to have x all by itself on one side. Currently, x is multiplied by 3. We can undo this multiplication by 3 by dividing both sides by 3. So I'll take 2y plus 6, divide the whole thing by 3, and I'll take the 3x and divide that by 3. Notice there's a common factor of 3 that can be canceled, and the result is we have x all by itself on one side, and we have 2y plus 6 over 3 on the other side. And this is our resulting equation. You can see that x is solved for, and you can see that the variable y sits in the right-hand side as this expression. So if you compare with the equation we started with, the variable y was solved for, and x was a part of this complicated algebraic expression, and we've just reversed the situation here so that x is solved for, and now y is part of a complicated expression. Later on, when we get to chapter 10, you will see that being able to do this kind of manipulation will be very helpful when we try to determine inverse functions. Now let's look at part B. Now we want to solve the equation for the variable w. So currently the variable r is solved for, but we want to rewrite the equation so that the variable w will be solved for. And the variable r will be sitting on the right hand side as part of this question mark. Okay, so if we want to get w by itself, we need to undo some operations. So you can think of it this way. So the equation is r equals, and I'm going to rewrite the subtraction as addition. So this is 16 plus a negative 3w. So I need to undo two operations. I need to undo the addition of 16, and I need to undo the multiplication by negative 3. I undo the last operation performed, which would be the addition of 16. What undoes addition of 16? Well, subtracting 16. So I'm going to subtract 16 from both sides of the equation. 16 minus 16 is 0. So we're left with r minus 16 equaling negative 3w. We're getting closer. In order to get w by itself, we need to undo the division of negative 3. Undo the multiplication by negative 3. And what will undo the multiplication of negative 3? Well, dividing by negative 3. So we're going to take both sides of our equation and divide by negative 3. Notice that gives us two factors of negative 3 in the numerator and denominator, which can be canceled. And this gives us w all by itself on one side of the equation, and then we have r minus 16 over negative 3 on the other side. So this is our resulting equation. W is solved for, and notice that r is part of this expression on the right hand side.